My name is Marinda Hall, and I'm the moderator here in Theatre 2. I was here yesterday for the opening. I'm here today, and I'm here tomorrow as well. A warm welcome to everyone live here in Amsterdam. We also have an audience on our recording. So we're not alone here. We have many people watching us on the recording later on. This recording is also available to you. All sessions here in Theatre 2 are recorded and available through the Intertraffic app that you probably have downloaded for these days here in Amsterdam. Today we have a kind of cluster of talks about data. About using data, and we have Dominic Abt here from Teledyne Fleur. You also have a stand. He'll probably tell you where the stand is, otherwise I'll ask him in a minute. And Dominic is going to tell us about sensor fusion and artificial intelligence for safer and smoother traffic signal control. May I have a warm welcome for Dominic Abt.
Thank you so much.
I made a joke. You have to come up like a rock star, and it's how it feels when this music's playing. Yeah, right. Yeah.
Great.
Told everyone you have you're here live in the Rai.
Yeah.
Can you tell us where you are?
So we are in hall 1, in the middle part,
Okay.
directly next to the big booth of Siemens. You see Teledyne Fleur on the top, so it's very easy to find our booth.
Good.
there.
Are you okay?
I'm okay. Thank you so much.
Take it away.
Yeah. Thank you very much. I'm here to explain you a little bit more about sensor fusion. Now I'm expecting some presentation would be nice. So, yeah, here we see already the agenda of my presentation. So I would like to tell you a little bit more about Teledyne Fleur, what we are doing, where we come from. I would like to explain you a little bit what is AI, what we are doing with AI, and what is our solution. So basically, I'm product manager for the urban market. I'm responsible for the urban sensors, and we have over 13 years experience on estimated 50,000 intersections. Our sensors are installed in over 80 different countries, and we can say it's estimated 250,000 sensors worldwide installed. So what I like to start with is our basic detection. We started, as I said, 13 years ago with, let's say, a very simple kind of detection. So what we did, we analyzed gray values in a visual image, and out of that gray value change, we gave a detection, and it's still the case in some of our older products, how we do detection. So then we moved a little bit forward with our detection that we were able to classify it. That was our first generation of AI, where we said, okay, that's a pedestrian, that's a car. And right now, we are much more, you can see it here, so we are much more forward with a new hardware platform that we are able to detect the traffic in the complete image. What does it mean? So we work with an AI model. What is an AI model? An AI model is something like, I really like to compare it with my little son. As I started to tell him this is a car, a small thing, it has tires, you can drive with it. So he learned it's a car. After a while, we had a police car, and he said, oh, it's a police car. Okay, he doesn't say it's a police car. He said it's a tatu-tata, but he recognized the difference between. So by showing new cars and more cars, we learn to distinguish, and the AI model is doing the same. So we are really, I think, the world leader in having thermal images in traffic situations. So we learn our own AI model. It's really like the human brain, that the neural network is learning what is a car in a thermal image, what is a bus, what is a pedestrian. So with all that data we collected in the past and what we have available, we trained our model. So it's really our own model where nothing else. So we really have control what we learn that model, and we can also later see, okay, what is missing. If there is something what customers are needing, we can implement that kind of functionalities. So starting with the car, we could say after, let's say, small investigation, okay, for 90%, this is a car, and 1%, this is something else. So as more you learn, as more things you train your model, as better the detection gets. So we have nice solutions. We are very famous for ball cameras, what you see on the left side. And we also have right now a solution to integrate the camera in a signal head. It has the big benefit that we are in a perfect position. I saw it very often that we are in conflict with the signal head. And because the signal head is exactly in the center of the scene. So, but also we, with our cameras, want to be on the same place. So we have always the disadvantage going to the left or to the right. So integrating the camera in a signal head was a logical step, and we do it together with our partners, Waco, for the Combia signal head. Let me go over the advantage which we have now with a second generation of AI implemented in our cameras. First of all, when somebody is asking me, what is now the advantage? I say, first of all, you are future-proof. And why you are future-proof? Because we make situational awareness. We have trajectories in our scene. And with all that information, the customer or we can provide the digital twin of an intersection. And all these is embedded in the cameras. Let me explain a little bit more about situational awareness and what does it mean. So first of all, we are able, with a new generation of the hardware, to analyze a complete picture. So we are able to recognize cars, buses, or pedestrian in a scene. We can classify them in specific areas, like also we can distinguish between a pedestrian and a bicycle or a motorcycle out of our learned model. And we have the position, speed, and heading. Here you can see an example where we started to train the model just to recognize cars. So we are also a little bit more flexible in the position of the camera. So you see here on the left side a little bit side-fired position, or we are over the lane, for example, with a lane com integrated in a signal head, where we are in a perfect position. You see on the left picture that there is a pedestrian which is also detected. So we are now, since we have situational awareness, able to recognize pedestrian in the brighter field of view. So we can also use the information how many cars are going away on the left lane. So that was impossible in the past. So classification, currently we have different classes in our AI model, like pedestrian, motorcycle, and big trucks, smaller trucks, vans. This is our focus right now, how we learn the model, and this is how we try to make our recognition smarter and smarter. You also can see here that, for example, persons on a pedestrian shoulder are recognized very easily, and the cars are also showing the speed and the heading. So we have a lot of information, so it's more rich of information what we can output. Basically, we are still giving the presence detection to signal light controller. That's our key business. But on top of it, we can provide big data, situational awareness. Also, the trajectories are very interesting for a lot of customers because they want to see how is the behavior on my intersection. How are the cars driving? Are they doing constantly forbidden moves, like a forbidden U-turn or something like this? all that information is now available for the customer to analyze it, to make changes on the signal light controller, and to check if the change is improving or not. As I said, with all that information we provide, that classification, speed and heading and trajectories, finally we can make a digital twin of the intersection. And that's, in my opinion, very important. Again, we still serve the signal light controller with inputs about presence detection like he is expecting it right now. We give the controller the information he needs, which is state of the art, but we are also ready for the future. So when the customer needs a more specific presence detection of maybe of a bus, or he wants to collect more data, or he likes to have some more availability of the trajectories, he wants to see how is the traffic behaving, we can do it with that camera on top of it. So we are still there, and we provide much more rich data. So everything, and that's really important, is it's embedded. We don't need to have an internet connection at all. We just need to provide the camera in the right position, and we provide firmware updates to make the AI better and better. So even if you install it the first time, it's not needed that you need to learn the algorithm or you need to have an internet connection or something like this. Everything is embedded and stored in the camera. It doesn't matter if we speak about the integrated camera or the ball camera. It's both the same. With the ball camera, we are also very flexible. We already have that ball camera since years, and we are very famous with that kind of housing within the traffic, within traffic situations. And with a new sensor for the Combia signal head, we are also very flexible to go to the left and to the right and low. So this kind of solution is available for visual and thermal image. So we have an AI model for visual cameras, and we have an AI model for thermal cameras. It doesn't matter which kind of camera you use, everything, again, from the AI model is learned from us. So our AI babies are only getting video footages, inputs from our side. So we have everything under control. It's not an open format, open source platform where you get the data from, how you learned the AI model. Everything is in our hand to learn the AI model in the camera. So also very important for us, and the major focus, as I said, we need to serve the signal light controller, is that we have an easy way of installing the camera. And it needs also to be easy to configure. That's also, like in the past, our major focus, to integrate the camera in a nice and easy way. And with that new generation, as I said, we can also fulfill, let's say, much more advanced detections. So if somebody is only interested, let's say, in a bus which is driving, let's say, 10 to 20 kilometers, we can make it with our cameras because we know where the objects are, we know the speed, and we know where the object is located. So we are very flexible with our detection. We have also much more advantages with that new AI generation, from the perspective where the camera is positioned. So even when you're in a perfect position, as you can see on the right or on the left side, it's really hard sometimes to reduce the conflict with a collision. So as you see the white truck here, he is quite high and he's covering the zones in the middle and he's triggering that zones. And in the past we were not able to reduce it. So on the right side you see that we detect the bus. The bus is driving in the middle and we know it's located in the middle. So the left zone here in black it's not triggered because of the occlusion of that truck. So we have a much better performance with our second AI generation. When we speak about classification and the ranges, I also need to say that we start to detect, let's say with our 390, our wide angle camera, we start to detect the objects after 60 meters. But we cannot say for 100%, okay, is it a truck or is it a car? We know there's an object. But as closer they are, as closer they to the camera, we can detect more classes. As you can see here in that picture, when they come closer to 40 meters, we already can distinguish between a motor, a car, and a big truck. And if they come closer, we have also up to 8 classes, and plus a custom class, which you can activate. Plus that we have position, speed, and heading. So here is just, I don't go in details of that slide. So it's just an overview what kind of detections we learn to our model, and we are flexible to provide specific classes to our customers. As you see really on the right side, we are also able to give the client a custom class. What is a custom class? A custom class can be a specific van, or as we see on the right side, a blue bus. So when, of course, if we speak about colors, you want to distinguish on colors, then we speak about visual cameras. But to have that detection of that specific vehicles, we simply need to learn it to our AI model. We need to train our AI model that this is a specific class, and we can provide this solution. So again, just to finish that presentation in the way, what is our major focus? So we want to make the world, the ITS world, smarter, safer on the intersections. And first of all, with our detectors, we provide input to the signal light controller. It will not change so much. Even with autonomous driving cars, we will not change it from one day to the other. So we still need to serve signal light controllers with expected detections, what we already do since 30 years. On top of it, the customer can, with all that huge data, with that situational awareness data, big data, he can analyze his intersection, and he can check, for example, after a football game, after a concert, if we can improve the cycling time for specific situation, that we have a smoother and safer traffic in the future. We also have in place a cloud solution to analyze that data, and now we have a closed cycle that after providing that data, after doing some changes, the customer can again look at the intersection performance to make the intersection more and more efficient. So it's a never-ending cycle, and this is only possible, in my opinion, with big data, a huge data, with sensor fusion from video images or thermal images and our AI technology. So this was my speech, and I'm open for questions.
So, thank you. Shall we give him a round of applause?
Thank you.
Do we have any questions? I'm speaking in the microphone, but I don't need to. I have one here. Anyone else who would like to use the microphone? Yes, could you introduce yourself as well, please?
Yes. Hi, everyone. I'm Diego from Movion, from Italy. And when you say your system is able to... Okay, that's right, thank you. We provide input to your traffic signal. You mean which kind of input? You suggest to extend, for example, the green light because the queue is too long, or you make this kind of calculation? Which is the input that you pass through the object controller of the traffic light?
currently traffic light controllers expecting dry contacts. So we are not that far with fancy protocols to provide a lot of more rich data. So we just give a dry contact. And that's still important because that's what the signal light controller is expecting. But the cities, all our customers, they want to make the intersections more efficient. You need to know that I can speak for Germany in that case. In Germany, they make traffic calculation all 4 years. They send some students. Sometimes they had a hard night before, and then they send the students there to count vehicles, and they need to distinguish between classes. And based on that numbers, from that one day, a representative day, of course, not in holidays, but based on that numbers, they start to calculate, to make the programming for the intersection. And you can imagine that if you have some maintenance work, that if you have some pop concert, the cycling time, which is programmed from that day as a basis, is not representative for such a situation. So you need to have adaptive systems. If you go to Swarco, Siemens, everybody is speaking about adaptive systems, but you also need to provide data for that adaptive system, and that's how we come into the game. So what I try to say is that we are there to serve the old way of controlling the intersection, but we are ready for the future. Thank you for your question.
Great, thank you. Anyone else? Question? I think that's it. Yeah.
Thank you so much.
Thank you for your presentation, and thank you for your questions. This is available online for later.
Perfect.
So, that's it. Can we have one more round of applause, please?
Thank you.
Thank you. We are back in 20 minutes, a bit more than 20 minutes. So if you want to stay put, you're very welcome. Or come back later or visit the show. See you later. Bye.